Okay, good afternoon, quantitative people. So today we're going to do a quick review of factoring. We have three different types of factoring. You've already done one. You did the factoring out the greatest common factor. You did that. So we are going to do the other types of factoring. So I thought I'd start off with factoring the difference of squares. And how do we recognize when we have the difference of squares? We recognize that when we see that the first term is a perfect square, and if it's a variable, that just means it has an even exponent. And the second thing is also a perfect square, and so obviously if it's a number, then it's going to be, 4, 9, 16, 25, and so on, all the perfect squares. So how do we recognize it? Both terms are perfect squares, and there is a negative sign between. So x squared minus 81 is an example of that. And how do you go about factoring that sort of thing? And so obviously, again, the most important thing to do is recognize that we have it first. Once we know what we have, then we can apply the method for factoring it. So the method that I use here is take the square root of the first thing, take the square root of the second thing, and then put a plus and a minus. So we're going to take the square root of x squared, which of course is just x. We're going to take the square root of 81, which is just 9. We'll put a plus, and we'll put a minus, and we are done. That's simple. So let's do another one. So not always is the first term just a variable squared. Sometimes there's a number in front of it. And again, we try to recognize whether this is the perfect difference of squares or not. And 4 is a perfect square, x squared is a perfect square, 25 is a perfect square, separated by a minus sign. So it is, so we just apply root plus minus. So we take the square root of 4x squared, which is 2x, take the square root of 25, which is just 5, put a plus, put a minus. And again, we're done. This is a very easy bit of factoring. Okay, so right now I want you to try this one on your own. It's very much like the one right up here. So pause the video right now and try this on your own. And it really is important for you to really try these on your own. So pause the video right now and do it, and I'll be right back and we'll go over the problem. So pause it now. So hopefully you've paused it and you actually did the problem on your own. And so when we work through this, we take the square root of this, which is 4x. We take the square root of 81, which is 9, and we put a plus, and we put a minus, and we are done. That's all we have to do. That's it. Hopefully you got it right. Now sometimes when we look at something that could be a difference of squares, maybe it is, maybe it isn't, so we see a x squared here, and we see a minus, and we think, well, maybe that's the difference of squares, but 72 is not a perfect square, and neither is 128. But if we factor out the greatest common factor first, then we get a chance to see that this might be the difference of squares. So we should start by factoring out the greatest common factor first. And so if we look here and here, we see that 8 actually goes into both of these things. So 8 goes into 72 9 times. We have 9x squared. And 8 goes into 128 16 times. So after factoring out the GCF, we see that we have now the difference of squares here, and we just apply the root plus minus thing. So the square root of 9x squared is 3x. The square root of 16 is 4. We do a plus, and we do a minus. And we're done. So difference of squares, easy enough. Okay, so let's go on to factoring basic trinomials, things that look like this. And so how do we recognize a basic trinomial? Well, it's got 3 terms. The first term is an x squared, as in 1x squared. The next term has an x, and the last term has a constant. So we have a 1x squared and an x term and a constant. 20 is a constant, there's no variable. And trinomial, of course, means that there are 3 terms, 1, 2, 3, and there they are. So how do we factor it? We use the two-part question. We ask ourselves what two numbers multiply to make 20, add to make 9. So I'm going to write down here two-part question. What two numbers mult to make blank and add to make blank. So in this case, what two numbers multiply to make 20, add to make 9. Obviously those numbers are 5 and 4. So we write x plus 5 and x plus 4. And because of the commutative property of multiplication, doesn't matter what order we multiply these in, so it doesn't matter what order we write them either. Same approach for this problem right here. Again, this is a regular trinomial. It's got 3 terms, 1, 2, 3. It's got an x squared with a 1 in front of it. It's got an x term. It's got a constant. So then we apply the approach, which is this one right here. So we ask what two numbers multiply to make negative 48, add to make positive 2. Well, we know that 8 times 6 makes 48, but which one's positive, which one's negative? Well, we said this is a positive 2 here. So if we had a positive 8 added to a negative 6, we would get positive 2. So there it is. X plus 8 and x minus 6. And we are done with that one. Now, again, this is really important. You try this on your own. So please take a moment, all by your lonesomes, to pause the video, try this on your own. It really is important for you to try these on your own. We'll be right back in a minute. Okay, hopefully you tried this and you were successful. So we look for two numbers that multiply to make negative 24, add to make negative 3. Hopefully you came up with x minus 8 and x plus 5. Oh, no. Something went horribly wrong there. 6, 4, 8, 3. This should have been a 5. Sorry. Well, you were going to have trouble doing that problem, weren't you? This is what I had intended. It should have been x minus 8 and x plus 3. That's what I intended. I don't know how it is that I came up with that other stuff. So, unfortunately, that was not a very successful try this one on your own problem. So, there it is. Okay. And again, just like we had in the previous approach with the difference of squares, sometimes we have a common factor that we need to factor out. So we look here at the 2, the 14, and the 24 and recognize that 2 can be factored out of that. So we factor out a 2, and we get x squared plus 7x plus 12. And actually, why don't we pause right here and have you do this one on your own. So pause the video right now, do this one right here on your own. This one actually works great, and do that right now. We'll be back with you in a minute. Okay, so hopefully you paused the video and things were successful. So what two numbers multiply to make 12, add to make 7? Obviously those two numbers are 4 and 3. And there it is. And remember, factoring, which is what we're doing, is finding things that multiply together to make a product. So these 3 things multiply together make that product right there. All right, we have one other method of factoring, which is, I wanted you to try this one. So factoring out the GCF first. So please take a moment to factor out the GCF. So pause the video right here, factor out the GCF, and try this one on your own. Okay. So you can see that as we look at 3 and 12 and 36, 3 is the common factor. So you factor out a 3, and you're left with x squared minus 4x minus 12. And then you ask yourselves, what two numbers multiply to make negative 12? Add to make negative 4. That's negative 6 times positive 2. So we got 3 times x minus 6 and x plus 2. And we are done. All right, one more type of factoring for quadratics. This is trinomial with a leading coefficient not equal to 1. So how do we recognize that? We got 3 terms, 1, 2, 3. We got an x squared, an x, and a constant term, and no common factors, and this number isn't 1. So I'm going to say same as trinomial, the regular trinomial that we just looked at. Leading coefficient is not 1. So there it is. There's the example. 2x squared plus 7x plus 6. This is an example of a trinomial where the leading coefficient isn't 1. All right, so how do we go about factoring it? We use the master product rule. And hopefully all of you saw this in Algebra 2. You certainly did if you had me or Ms. Pender. We do the same approach for this. So the master product rule starts off by taking the first term, multiplying it by the last term, and we end up with 12x squared. And then we ask ourselves the two-part question that we did before. What two things multiply to make 12x squared, add to make 7x, and those two things are 4x and 3x. Hopefully this is all coming back to you. And then we take the 4x and the 3x and we replace the 7x with those, and we write a new quadratic, 2x squared plus 4x plus 3x plus 6. And now we see that we have 4 terms, and so what we do is we divide and conquer. We cut it up into 2 different groups of 2, and we GCF this one. So what is the GCF of 2x squared and 4x? Well, obviously 2x. And then you ask yourself the questions that we did when we did the GCF. 2x times what makes 2x squared? Obviously x. And 2x times what makes 4x? Obviously that's 2. And we do the same trick over here. And we see that 3 goes into both of these, and we have a 3 times x plus 2. And then we notice there's an x plus 2 here and here, so we factor that out. It's a common term or a common factor. So we factor out the x plus 2. And what do we have left? That and that. 2x plus 3. And we are done with our first master product example. Now, I would like you to try this on your own. This is the last thing we have to do. So please take a moment right now, try this on your own. Pause the video, try it, and we'll be right back. So hopefully you had time to try this, and you actually did try it on your own, and so we'll go through the whole process together. So we multiply these two together, and we get negative 24x squared. Starting to feel a little bit like Bob Ross right now, only not as creative. And I don't have a fro, or, well, that much hair for that matter. So negative 24x squared. So what two things multiply to make negative 24 and add to make negative 2? That's negative 6x and positive 4x. And then we put those in there. So we have 3x squared minus 6x plus 4x minus 8. And then we divide and conquer. And we factor out the GCF here, which is going to be 3x times x minus 2. And we factor out a 4 here, positive 4, times x minus 2. X minus 2 is in common. And what's left? 3x and 4. There it is. Hope you got it right. So there's your quick review of factoring, and the assignment is already posted. See you in 2 days.